I'm going to show you the truth tables in this program here on the internet, and I'm also going to show you the corresponding truth tables that are in the presentation. Now, we have to be very careful because there are lots of different ways of writing them down. They all mean the same thing, but they tend to use different words at different times. So I'll show you what I mean. I'm going to highlight just this top item, the NOT gate. So I'm going to highlight the lamp all the way over to the switch, and I'm going to press this little button on the toolbar, which will give me something called the truth table. And when I click it, what we've got here, the I1 means the input, and what we've got here is a switch for input. There's only one, so it's called I1. And we've only got one output, so the O stands for output, and the 1 is the first one. We could have lots of different outputs. But this is called a truth table, and it tells me what happens when I turn the switch on or off. And instead of using on or off, it's using the values false or true. So false would be off, true would be on. And in some cases, they actually use ones and zeros from binary to represent these values. So false would be 0, true would be 1. And you're going to see all of those different cases as we go through the course. And again, you'll see them written on the exam paper, and preferably on the exam paper, they would like you to use ones and zeros. And we will see those in the PowerPoint in a second. So let me take you through what this means. So this is my input 1 in this column, and I've got the two cases that the switch could be. It could either be false, off, or it could be true, on. If it's off, then the lamp lights up. In other words, it's true, it's on. If the switch is turned on, then the result, the lamp, the output is off, it is false. Now, that's probably a bit strange to you at the moment, but really it's just the opposite. So if the input is false, the output is true. If the input is true, the output is false. And that's the truth table, and this is a table with the headings, inputs and outputs, showing you the values. So I'm going to switch over now to the PowerPoint, which you've got. And on this particular slide, which is slide number 12, it is showing you exactly the same thing. So here's my diagram, and what they've used is Y instead of Q. I used Q. And here's my table. So the very first column is A, that's the input. That was I1 on the truth table in the website. And here I've got Y, or output 1, but I've got a strange symbol. I've got kind of like a little rectangle, corner of a rectangle before the A. That is a symbol for not. So that says not A, not A. And that's not an OR gate. That just means you can either write not A, the word not A, or Y or Q or whatever you use. We'll come to that a little bit later. But let's take a look at the table. That's the really important part. Here I've got 0, which was false in my original table, false, which is 0, and the output would be true, which is 1. So 0 is false, the output is 1. And there's the opposite. So my input is true, my output is false, 1 and 0. Now, it really doesn't matter how you represent these. In fact, true and false is best if you are programming, but if you're on paper and doing this table, ones and zeros are the best way to write them down. So that is the NOT gate, and that is the truth table for the NOT gate. So I'm going to quickly go now to the second one, the AND gate, and I'm going to highlight all of that circuitry, that gate, and I'm going to take a look at the truth table, and it's a little larger because we've got I1, which is the first switch underneath here, and I2, which is the second switch, which we can see here. And then I've got O1, the output, which is my bulb. So this is saying if the first switch is off and the second switch is off, which it currently is, then the output, the lamp, is off. If the first switch is off, but the second switch is turned on, the lamp stays off. If the first switch is on, but the second switch is off, the lamp stays off. If the first switch is on and the second switch is on, then the lamp lights up. So in other words, we can see here that the lamp turns on only when both switches are turned on. So let's take a look at that AND gate in the PowerPoint. And again, we've called it AND, and it's got a symbol, and this symbol is very difficult to write on a computer, but it's sort of an upside down V. So that reads A and B. That upside down V stands for AND, and we tend to use that the symbols in our table. So here I've got my first input, A, and I've got my second input, B, and I've got my output, Y, or A and B. And if you think about it, this is just the equation that we wrote on the actual slide. So Q equals A and B. That would be very useful to write that as this title. So if we take a look, we've got off and off, and the lamp stays off. We've got off and switch 2 on, lamp stays off. We've got on and off, lamp stays off, and we've got on, and the lamp comes on. So the lamp only comes on when both of the inputs are on. So let's take a look at the third one quickly, the OR gate. So let's highlight the OR gate and take a look at the truth table. So this truth table says that if the two switches are off, the lamp stays off. Then it says if the first switch is off but the second switch is on, the lamp comes on. If the first switch is on and the second switch is off, the lamp comes on. And if both switches are on, the lamp comes on. So the lamp comes on if any one of the switches is on or both of them. The only time it doesn't come on is if both switches are off. And we can see that in the truth table for the OR gate. So here's my OR gate, and this time the equation is written as A, and this V symbol stands for OR, A or B. And we can use that as the header of our table. So let's go through again. So off and off means that the lamp is off. Off and on, so I've got one switch on, the lamp comes on. On and off, the lamp comes on because I've got one switch on, and both switches on, the lamp comes on. And that is my OR table using zeros and ones, or binary. So that's a quick introduction to truth tables for you. You need lots of practice doing this, in particular how to write these equations out, or how to write these tables out and set these ones and zeros up. But that will be something that I will show you as we go along.